Hi, I'm Robert Hart. I'm a researcher at Berkeley Lab specializing in Windows. This video will focus on Windows for colder climates. In the world of Windows, thermal performance is measured by the U factor and the solar heat gain coefficient. U factor is a measure of how well a window insulates. The lower the U factor, the better the window is at keeping your house warm when it's cold outside or cool when it's hot outside. Low U factor windows are important for energy savings and comfort in all US climates, but especially so where it's cold, because the indoor to outdoor temperature difference in cold climates is usually much higher than in warm climates. Poorly insulating or high U factor windows, such as single pane or double pane clear, waste a lot of energy, but they can also contribute to other more serious problems like condensation, which is unsightly and facilitates mold formation around the window. Interior or room-side condensation usually occurs in the winter when cold outdoor temperatures cool the room-side window surfaces below the dew point of the warmer room air. Double pane windows with low E coatings, which is the window most often installed in the US today, significantly reduces the chances of condensation. But condensation is still possible even with these windows in cold climates. The spacer between glass panes is often the weakest thermal link in window systems, and therefore the greatest risk of condensation occurs at the edges of the glass. Some windows will provide an additional room-side facing low E coating to lower the U factor. This does reduce heat transfer, but it also lowers the glass surface temperatures on the room side and can exacerbate room-side condensation. Condensation on the outside of a window can also occur. Highly insulating windows do not allow much heat to flow from the interior, which makes it possible for the exterior glass surface to fall below the outdoor dew point temperature due to radiation loss under clear sky conditions. The latest high-performance window technologies all but eliminate the risk of interior condensation and show significant energy savings in cold climates due to their low U factors. Triple pane windows with low E coatings in each cavity and lower conductivity gas fills perform very well in colder climates. There are also emerging technologies such as thin glass triple pane and vacuum insulating glazing that can achieve low U factors in a thinner space than traditional triple pane windows. Thin glass triples can use a center layer of glass as thin as 1 millimeter. Combined with argon or krypton gas fills, thin glass triples can achieve much lower U factors than double pane while still utilizing the existing frames designed for double glazing. Vacuum insulating glazing, or VIG as they are commonly called, is the most insulating glazing technology on the market today. This emerging technology consists of 2 glass layers separated by a vacuum and an array of tiny pillars. The vacuum, combined with a low E coating, nearly eliminates all heat transfer across the glazing. VIG can be retrofitted into frames designed for single pane glazing and can also be assembled into hybrid units for retrofitting into frames designed for double glazing. Transmitted solar radiation through a window is referred to as passive solar gain, and during the winter months, passive solar gain can offset heating demands from other sources. Lower solar altitude angles in the winter generally means more solar intensity on the window, potentially emitting hundreds of watts of free heating into the space on a cold but sunny day. Building design can have a significant impact on energy use associated with windows, including facade orientation, window size, roof overhangs, and other external shading such as trees or neighboring buildings. Insulating shades can be added to windows to decrease energy loss at night or in cloudy conditions when passive solar gain is not possible. Cellular shades with side tracks are one example of a highly insulating window attachment. At Berkeley Lab, we are working on many ways to reduce energy use associated with windows. Check out our latest research at windows.lbl.gov, and if you have any ideas, we'd love to hear from you. We hope this overview has been helpful. To learn more, visit Berkeley Lab online or view the next video.